Good morning, children. Welcome back to ICAN Physics. Now in this class, going to solve question number 12 and 13 and the internal resistance of the cell. Let's enjoy the class. The next question is the internal resistance of 2.1 volt. Okay. So the psi is 2.1 volt. Okay. Which gives a current of 0.2 ampere. So I equal to 0.2 ampere. Through a resistance of 10 ohm. Okay. Resistance of 10 ohm. Calculate the internal resistance. Okay. So the internal resistance is denoted by small r. Okay. So how we can calculate? That is the internal resistance equal to psi minus IR by I. Okay. So by that we can calculate psi. So what's the value of psi? 2.1 minus I. I value is 0.2 into R. R value is 10 divided by I. I value is 0.2. Okay. So 2.1 minus 0.2 into 10. It becomes 2 divided by 0.2. So 2.1 minus 2. So 0.1 divided by 0.2. So in the numerator and the denominator we are having one decimal point. So it is multiplied by 10 and divided by 10. So it becomes 1 by 2. 1 by 2. So when we cancel 1 by 2, it becomes 0.5. So the internal resistance is 0.5 ohm. Okay, do you get it now? So the next question is, a piece of copper and germanium are cooled. Okay, so cooled from room temperature to 80 Kelvin. Room temperature to 80 Kelvin, and the resistance of copper and germanium is dash. Okay, so we know that copper is a conductor. Copper is a conductor. Okay, for conductor, when the temperature increases, the resistance also increases. Okay, but what is the question given? It's cooled. So when it is cooled, so temperature decreases. So when the temperature decreases, automatically the resistance also decreases for copper. So for copper, the resistance decreases. Okay. On the other hand, we can see the germanium. Okay. So germanium is a semiconductor. Germanium is a semiconductor. For semiconductor, when the temperature increases, the resistance decreases. Okay. So for our case, it is cooled from room temperature to 80 Kelvin. So the temperature decreases. So automatically the resistance increases. So for germanium, the resistance increases. So for copper, the resistance decreases. For germanium, the resistance increases. So this will be the answer. Okay, do you get it now? Do you get it out? No doubt.